Hello everyone, this is my project C2F.Pay, bridging crypto to everyday commerce through AI powered payment orchestration. And this is me. My name is Pushkar, and I'm a third year BS Physics student from Indian Institute of Technology, Roorkee, India. And here are some of my notable achievements, like I'm the first prize winner in the Eliza West track in Chainlink Romeo Hackathon, and also Coinbase prize winner in Agentic Ethereum. And this is me in real, and here you can see my institute ID. This is my image and my name and my branch, and let's move forward, and let's understand where are we heading in the future. The future is of MCPs and crypto. Basically, in the future, everything from shopping to booking a ride will be handled by AI agents, and these agents will just use MCP servers as standard connectors to wallets, merchant services, and blockchains. And talking about crypto, these are pure digital assets with no physical form. You can literally send value to someone on the other side of the world just as is they are sending it to your neighbor, and it happens almost instantly. You can even embed rules and conditions directly into the currency itself. But there is a limitation in with crypto in payments. Can crypto buy you a coffee? No, crypto can't buy you coffee yet. Despite all the excitement, you still can't use it for your everyday purchases. You walk down any street, go to any coffee shop, grocery store, or anywhere. What do you see? Everyone is still pulling out cash, swiping credit cards, or tapping their phones for payments, all using traditional fiat currencies like dollars, euros, or rupees. Here in the image, you can see if one person has crypto and the other one person has any fiat currency, they can't have any buy deal, a buy sell deal. So that's one of a big limitation right now. So what is the solution? Solution is C2F.Pay, which is a combination of blockchain, MCP, and fiat payment. It's an MCP powered crypto to fiat payment platform, which enables seamless crypto to fiat transactions with just natural language prompts that allow users to buy real world products with crypto while merchants receive traditional payments. So this is the proposed solution architecture, and here you can see some of the MCP servers like SA MCP server, Layer MCP server, and Merchant MCP server, and they all interacting with the user on the MCP client side. The user on the MCP client side can find and buy products on the Merchant MCP. On buy product request from user, Merchant MCP server creates a payment intent using Stripe and share its ID with the user. The user can then send it to the layer MCP, which will eventually share the ID with all the resolvers. So as soon as one of the resolvers accepts to pay in fiat in exchange of crypto in place of user, the relay MCP server creates a order in the locker contract and shares the equivalent amount of SHA to the user. The user then use the SHA MCP server to lock the equivalent SHA in the locker contract. The relay server listens for funds locked event, and once the contract emits funds locked event, the relay MCP server signals the resolver to confirm the payment intent. The resolver then confirms the payment intent, and as soon as the relay MCP gets to know that the payment has been successful, it triggers a function on the locker contract to release the fund to the resolver who just paid uh, in fiat for in place of user. Layer MCP server also sends an email to the user email ID to inform the user that the payment has been successful. So this is all about the proposed solution architecture, and now it's time for demo. So here you can see we have three terminals, one for merchant MCP server and one for relay MCP server, and one is a resolver server. And here is our MCP client, which is Claude, and here you can see it has been connected to three servers, merchant, relay, and say MCP server. So let's say find an apple from any seller, and let's see if Claude can find any apple from the merchant's MCP. And here you can see it is asking us to run the find product tool on the merchant MCP. We will allow it, and you can see it has found the product. And here I can also price 0.50 USD, description fresh new apple for customers with a product ID of Stripe, and here you can view the image too. So let's open the link once, and here you can see, and here we have the apple image. Now close it and tell the Claude to buy one for buy one, and let's see what happens. Okay, so it is asking me my email address. So let's provide it an email address. Uh, use And here you can see it is again requested us to allow it to run this tool. And here you can see the request we are sending is the ID of the product and our email ID. So let's allow it. Okay, so the merchant MCP has created a payment intent ID using Stripe, and here we have the payment intent ID, and we have to pay 0.5 USD to buy it. Okay, send it to the payment facilitator layer, which will it will call a tool on the relay MCP server, which is relay payment intent tool with the request containing payment intent ID. We will allow it, and as soon as and here you can see the relayer relays that payment intent to the resolver server, and the resolver has given an option of yes or no. So let's accept the order, and we have accept the resolver is accepted to pay for this product payment intent ID, and here you can see order created successfully. So here we have got the order hash. We have created an order on chain, and this is the order ID, which is same as the payment intent ID. And now you can see now it's saying us to next step to complete payments. You need to lock 1.5 say in the locker contract. Okay, lock the chain amount, and here you can see it is running write contract tool on the say MCP server, and we will allow it. So finally we have completed. We have locked our say amount on the in the locker contract, and let's see what happens on the resolver layer side. So so here you can see payment confirmed for order ID means you can see the resolver has paid for this payment intent ID, and message sent means the message has also been sent to our email ID, to the user email ID, and payment to resolver has also been successful, and this is the transaction hash. Let's go to say press, and this is the contract, and let's refresh it. After refreshing, you can see we have three transactions one by one, and 58 seconds ago, 1 minute ago, and 2 minutes ago. And if we check one of the transaction, you can see payment to resolver, which is called by the relayer MCP server. Let's go to our let's go to our email ID and check. And here you can see C2F.Pay at gmail.com to me. Your fiat payment on Stripe for order ID. This has been done by our resolver. Soon you will receive the product you order. So, and this is how we can do payment, crypto to fiat payment orchestration, all just using MCPs, using just prompts. I've modified say MCP server a little bit so that I can be able to send a native token value while calling a function on in the contract. So my I have also raised a PR which basically enhances the write contract tool by allowing native token value to be sent alongside contract function calls. And here you can see I have added a value parameter which I then passed in the contract params, and which eventually gets passed to the write contract. Using this, we are able to send value to any contract alongside function calls. So, and this is everything about my project and my changes, and hope you liked the project.